Hello?
Good morning, dear students. Yes. So, as we have completed PU1 and PU2 syllabus for KCET, okay. So today we are going to solve. So today and one more day, okay. So this will be a continuation. Okay. So 2 days we are going to solve the one of the model question paper for KCET, okay, based on your recent pattern, that is on your reduced syllabus. Okay, so altogether, as you all know, for your PU1, okay, yes, very good morning. Okay, so altogether you have 19 chapters, okay, for from PU1 and PU2, okay. So based on that, we are going to solve the model question paper, okay. So whatever the synopsis have been sent for you already, okay. So the synopsis are there with you. So please go through the synopsis, okay. And so in that synopsis, important concepts are okay, we have considered the important concepts. So please go to the concepts. So if you read that, you will like all the things will be cleared. Okay, so it will be brushed up. So whatever you are you have studied in the 2 whole years, so that is sum up in the short synopsis. So based on that, then we have solved MCQs also. So from your side also, what you need to do is so refer good books. Okay, refer books and this okay so now it is last time, so what you have to do is you have to solve the previous papers only. Okay, so now I hope you have already done this, okay, solving the good number of questions. Okay, so more number of questions. So now if so you are left with very few times, so what you can do, you can solve some previous question, previous year's question. Okay, so that you will get idea what type of questions are asked. Okay, okay, so as you know, so for the paper, okay, KCET paper, you'll be getting 60 questions. Okay, so how the questions are there, so let us see. So let us start with the paper. Okay, so this is the first question, that is the IUPAC name of CH3 CHOH, okay, CH2 CHCOH CH3E. So what is the IUPAC name? So there are 4 options. Go through the 4 options. Okay, 4-hydroxy, 1-pentanoic, 1-pentanoic acid, 4-hydroxy, 2-methyl pentanoic acid. Third one, 2-hydroxy 4-methyl pentanoic acid, or fourth one, 2-hydroxy 2-methyl pentanoic acid. Yes. What is the answer? What will be the answer for this? Yes, you can use the chat box. As you all know, you can use the chat box for answering the question. Okay. Okay. Shashti, Velingakani, Navyashri, Vidya have answered it as D. Okay. So they have answered it as D. Okay. So the answer is 2. That is second one. So you can see how the naming they have given. Okay, how the naming they have given is the naming starts from, so you have two groups. Okay, two functional groups. So one you have is carboxylic acid, another you have is hydroxy group. Okay, so so carboxylic acid, okay, it is considered as a parent. Okay, so this is a parent chain, carboxylic acid. Okay, and hydroxy is your substitute. Okay, so the parent chain should get the least number. So how they have given? So it is 1, 2, 3, 4, 5. So they have considered it as 1. Okay, so 1, 2, 3, 4, and 5. Not from here, sorry. This one. See here. So it starts from 1, 2, 3, 4, and 5. Got it? So what is the name? So it is 4-hydroxy 2-methyl pentanoic acid. Okay. So it is, what is the answer? So it is option number 2. Option number 2. So how they have considered? They have considered the parent chain. So that is the carboxylic acid. They have considered as a parent chain. So there are 5 carbon atoms. So it is pentanoic acid. Okay. So at fourth position, you have hydroxy group. At your fourth position, at your second position, you have methyl group. Okay. So this is a 4-hydroxy 2-methyl pentanoic acid. So option number second one. Is it clear? So option number second one is the correct answer. Okay, fine. Let us go for the next one. So next one is alkali metals have negative reduction potential and hence they behave as. Alkali metals have negative reduction potential and hence they behave as. A, one oxidizing agent, 2 Lewis acid, C reducing agent, and 4 electrolyte. Alkali metals. They have high negative reduction potential. Okay. So your everyone, Madan, Vidya, Srishti has answered it as 1. Okay. So alkali metals. Any more answers? So the answer is 3. The answer is what? 3. That is, okay. So the answer is 3. So we know that as alkali metals, they have the high negative reduction potential. Okay. So they have very high reduction potential and hence they can easily lose electrons. Now you know what are alkalis, right? The S block element. The S block element, the group 1. Group 1, okay, they are called as the alkali metals. So alkali metals, what they are? So they can easily give electrons. Suppose sodium. Sodium is 11. So 1s2, 2s2, 2p6, 3s2, okay, 3s1, sorry, 6, 7, 8, 9, 10, 11. So so you can see that the inner orbits, okay, they are completely filled. It is satisfying the octet. So it can easily give this 1 electron. So it can lose electrons. So because the alkali metals can easily lose electrons, okay, so they behave as a reducing agent. How they behave as? They behave as a reducing agent. Okay. So option number 3. Okay, option number 3. So let us go for the next one. So next question, read out. Which of the following gases has the highest value of RMS velocity at 298 Kelvin? Which of the following gases has the highest value of RMS velocity at 298 Kelvin? methane, carbon monoxide, Cl2, carbon dioxide. Okay, Srishti has answered it as 1. Okay, Madan has answered it as 2. Any more answers? Which of the following gases has the highest RMS velocity? Okay, Ranjita has answered it as 3. Vidya has answered it as 2. So the correct answer is, so let us see the correct answer. It is 1. Okay, the answer is 1. The answer is 1. So the answer is 1. So the correct answer is what? 1. Okay. So, so we know that, okay, methane. So when we find the velocity RMS, okay, that is root mean square of velocity. So it is given as square root of 3RT upon M. It is given as 3RT by M. So velocity will be highest for lowest molecular. You can see that velocity is inversely proportional to molecular mass. Okay, so high velocity will be highest for the lowest molecular mass. So if you consider the molecular mass of the all the 4 molecules here, okay, so the carbon is what? It is 12 plus 16. Okay, so your chlorine will be 35.5 plus 35.5. Okay, then carbon is here 12 plus 16 plus 16. Okay, and here it is 12 plus 2. So it is 14, right? So the least is what? It is in methane. So the so lowest the molecular weight, highest will be the velocity. So option number A is the correct answer. Okay. Let us go for the next one. Cycloalkane formed. Cycloalkane formed when 1,4-dibromopentane is heated with sodium is. Cycloalkane formed when 1,4-dibromopentane. 1, 2, 3, 4, and 5. 1, 4 means at one position, and 2, 3, 4. This position you have bromopentane. So CH3, CH, CH2, CH2. Yes. Okay, Shashti has answered it as 3. Madan, Ranjita, Vidya have answered it as 3. So cycloalkane formed when 1,4-dibromobutane, pentane, has heated with sodium is. Option number 2. Okay, you will get a cyclopentane. You will get what? You will get a cyclopentane. Fine. So 1,4-dibromopentane. Okay. No, just a second. We will see, solve it out. Cycloalkane formed when 1,4-dibromopentane is heated with sodium is. So let us see first. Okay, the option I'm getting somewhere. So this is your structure. Okay, let me write it again. So the structure is CH2, 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 CH2Br, and your one Br. Okay, so it is one, two, three, four. Okay, so what you will get here? So in the presence of sodium and so what you will get? You will get plus 2NaBr. Okay, you will get a methyl cyclopent butane. Okay, yes, option number one is the correct answer. So, okay, so option number one is the correct answer. So let us go for the next one. So in the reaction, 2FeSO4 plus H2SO4 plus H2O2 giving you Fe2SO4 thrice plus 2H2O, the oxidizing agent is. So which is the oxidizing agent? So this is the reaction. In the reaction, 2FeSO4 plus H2SO4 plus H2O2 giving you Fe2SO4 thrice plus 2H2O, the oxidizing agent is. Okay, Vedvati has answered it as 4. Ranjita and Vidya have answered it as 2. Shashti has answered it as 2. Yes, V. Lingapani has answered it as 2. So the reaction is, so this is the reaction. I'll just write it here. Okay. So here the reaction is 2FeSO4 plus H2SO4 plus H2O2. Okay. Hydrogen peroxide giving you Fe2SO4 thrice plus 2H2O. So which is the oxidizing agent? Okay. So the oxidizing agent, which is the oxidizing agent? So it is H2O2. Okay. Option number 2. Option number 2. So if you see the what we have to do, we have to find the oxidation state. Okay, now SO4 is -2, this is +2, this is -2, this is +2, this is -1, so this is +1. Then your sulfate, so Fe2SO4 thrice it is. So 2x plus 3 into SO4 is -2 equals to 0. So 2x minus 3 2 is 6 is equals to 0. So 2x is equals to 6. Then x is equals to 6 by that is 3. So this is plus 3. So each is plus 3. Okay. Then your H2O is plus 1 and this is -2. So what is oxidation? Increase in oxidation number. Okay. So this is oxidation. And what is happening to your oxygen? This is getting, okay. So -1 to -2. So this is getting reduced. Okay. So this is oxidation and this is reduction. What is oxidizing agent? It oxidizes other and it undergoes reduction. Okay, so which is the this? It is H2O2. Okay, it is H2O2. So let us see the answer. Yes, it is third one. Okay, it is third one, H2O2. So yes, third one is the answer. So whoever have answered it as third, H2SO4 is a dehydrating agent. Okay, it is acting as a dehydrating agent, or it acts as a what you say, like to provide the acidic condition. Okay, to provide the acidic condition. So H2SO4 is not acting as a this what your oxidizing agent. It acts as either a dehydrating agent, or it acts as a, here it is acting as a, it is providing a acidic medium. Okay. Next question. Given thermodynamic equation, so given thermochemical equation 2H2 plus O2 give 2H2O, that is delta H is equals to minus 571.6 kilojoules. Heat of decomposition of water is, given thermochemical equation 2H2 plus O2 giving you 2H2O, delta H is equals to minus 571.6 kilojoules. Heat of decomposition of water is. Okay, Srishti has answered it as 3. Yes. Others, what is the answer? Fast. You should be very fast, because okay, so the time limit is also less. You have to be what, very fast during your exams, because you'll be having 60 questions. Okay, Ranjita has answered it as 2. So let us see the answer. Okay, so let us see the answer. Vidya has answered it as 2, and Ranjita has answered it as 2. So let us see. So the answer is 4. Okay. So the answer is 4. That is plus 285.8 kilojoules. So what you can give, what is given here? So this is a reaction, or so what is the heat of decomposition of water? So 2H2 gas plus O2, what is given is 2H2O. So delta H is given, that is delta H is given. So water, okay. So water will decompose how? So that is water H2O. Okay, liquid will decompose as H2 plus half O2. Okay, and so they have asked what is the delta H. So if reaction is reversed, okay, so if this is a given thermochemical reaction. Now if this reaction gets reversed, then what we do, then we divide it by 2. Okay, we divide it by 2. So what is this value? So this is the minus 571.6. So divided by 2, the sign of delta H changes. Okay, because for delta H, for decomposition of water. So what happens? So when the reaction gets reversed, or automatically the sign also changes. So the answer is 2 to the 4. So 2 8s are 16, 2 5s are 10, 2 8s are 16. Okay, so it is 285.8 kilojoules. Understood? Yes, is it clear? So whenever a thermochemical reaction is proceeding, so this is the proceeding reaction. Now they have said heat of decomposition. Decomposition means what? The water will again give back your H2 and half O2. So when the reaction is getting reversed, so what is happening? The whatever the value we have got, delta H values, and that we have to divide it by 2. That we have to divide it by 2, and the sign also gets reversed. Okay, so option number 4 is the answer. Okay, let us go for the next one. So in Buna S, okay, so this is from polymer solvate. So next question, the electronic configuration of Cu plus 2 ion is. The electronic configuration of Cu plus 2 ion is. Yes, what is the electronic configuration? How do you write for copper? Very important. So copper and chromium you have to do. The electronic configuration of Cu plus 2 ion is. Yes. Shashti has answered it as 4. So let us write. So electronic configuration of copper. So copper atomic number is 29. So 1s2, 2s2, 2p6, 3s2, 3p6. Okay. 4s2 and 3d5. Right. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 6, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25. So 1s2, 2s2, 2p6, 3s2, 3p6, 10, 3p6. So this will be 3d. Ten. So let us see 10. So copper plus 2 means what will happen now? Yes, copper plus 2. So the ions will go from where? So the ions will, one electron will go from here and another will go from here. So it will be argon 18. Okay, argon 18 and 3d9 and 4s 0. So one electron from here, one electron from here. Okay, so option number 2. Option number 2 is the answer. Okay, option number 2 is the correct answer. Got it? Okay, so let us go for the next one. The yield of the products in the reaction. Okay, so this is the reactant. So A2 plus 2B giving you C plus Q kilojoules would be higher at. So the yield of the products in the reaction A2 plus 2B, okay, giving you C plus Q, then kilojoules would be higher at. Yes. So yield of the products in the reaction A2 plus 2B giving you C plus Q kilojoules would be higher at. Vidya has answered it as 2. So the condition is it should be higher at low temperature, okay, and high pressure. So option number 3. Okay, option number 3 is the answer. So option number 3 is the answer. So the yield of the products, okay, in the reactions, that is 2A, A2 plus 2B giving you C plus Q. So it would be higher when you have low temperature and high pressure. Okay, when you have low temperature and high pressure. So we know that the forward reaction is an exothermic process. Okay, it is an exothermic. So what is happening here? The heat is released, right? So this is an exothermic process. You can see here Q is given up, right? So heat is released here. Heat is released, so it is an exothermic process. So in case of exothermic process, what is the condition? It should have low temperature and okay, low temperature so that it favors the product formation. So we know according to Le-Chatelier's principle, okay. So that is the pressure will be increased. Pressure increases with the uh, uh, okay, and it shifts the equilibrium to the side of the reaction with a fewer number of moles of gas. Okay, so and thus it requires a high pressure. So when you apply the pressure, what will happen? It will increase the equilibrium to the side of the reaction. Okay, where number of moles are less. Right. So because of that, low temperature and high pressure. So option number D, 3. Okay, option number 3 is the answer. Let us go for the next one. So next question, mesomeric effect involves. So what does mesomeric effect involve, students? What does mesomeric effect involves? Mesomeric effect involves delocalization of pi electrons, delocalization of sigma electron, partial displacement of electron, or delocalization of pi and sigma electrons. Yes. Vilinga Kani has answered it as delocalization of pi electrons. Yes, it is correct. So it involves the delocalization of pi electrons. Okay. So what it does, so the mesomeric effect, the electrons, that is the negative charge, okay, when a substituent is electron withdrawing group is attached, okay, and so it will be a that is delocalization of pi electron takes place. So in this mesomeric effect, two types of mesomeric effect is seen. One is plus M effect, another is minus M effect. So when is minus M effect seen? When you have a electron withdrawing substituent, and when is plus effect seen? When you have a electron releasing substituent. Okay. So based on that, so it involves the delocalization of pi electron. Okay. So let us go for the next one. Which one of the following sets of ions represents the collection of isoelectronic species? Now, what do you mean by isoelectronic species, students? Isoelectronic species are those species which have same number of electrons. Okay, same number of electrons. So, isoelectronic. So, the number of electrons are same. Can you tell me the which is the correct set of isoelectronic species here? Yes. Isoelectronic species. So which is the correct set of ions here? Yes, which is the correct set of ions in the given series. So there are 4 options. So please go through that and tell me the answer. Okay, Vidya has answered it as 2. Others? Okay. So let us see the answer. So the answer is third one. Okay, the answer is third one. So potassium plus calcium plus 2, scandium plus 3, and Cl minus. Okay, so how these are isoelectronic species? Yes. Yes. K plus ions, Ca plus 2 ions. So how do you write? So tell me the this. First, we need to know the molecular, that is the atomic number. Okay, based on the atomic number, you can of write the distribution of electrons. So we need to know the atomic number as well as the your this what mass number. So when we write K plus ions, okay, so the number of electrons is 18 here. Okay, so the number of protons is 19. Okay, so one electron is lost, so it will be 18. Then your this chlorine is how much? It is 16. Sorry, 17. So chlorine is -1. So it has gained one electron, so it becomes 18. Then calcium +2. Okay, calcium is 20. Okay, so it is lost 2 electrons, so it becomes 18. Okay, then is your scandium, Sc. So scandium is how much? Is 20. Yes, 21. So scandium is 21. Okay, scandium is 21. So +3 means 18. Right. So you can see the number of electrons in each case is same. So option number D is the answer. Okay, plus means what? Loss of electron. You have to subtract those many. Minus, so here is -1. So you have to add that many. Okay. Okay, next one. Say adsorption theory. This is from surface. So leave this. So we can convert methane to ethane by which of the reactions? Yes, methane can be converted into ethane by the reactions. Chlorination followed by reaction with alcoholic KOH. Methane can be converted into ethane by the reaction. Chlorination followed by reaction with aqueous KOH. Chlorination followed by Woods reaction. Chlorination followed by decarboxylation. Yes, which is the correct answer? Okay, Vilingakani has answered it as 1. Okay, others? So how does methane can be converted into ethane? Okay, so methane, what is methane? So methane is this, it is converted into ethane. So this is ethane, how it can be converted? Methane can be converted into ethane by the reactions. Vamshi Krishna has answered as 2. Vidya again has answered, okay, Vidya has answered it as 3. Naveshri has answered it as 2. Okay, so yes, so many have answered. So let us see. So methane, first you can treat it with chlorine gas. Okay, you can treat it with chlorine gas in the presence of UV or light. Okay, you can treat it with UV or light. Then, so thus what you can do, you can convert your methane into chloromethane. Okay, it is converted into CHCl, CH chloromethane. That is CH3Cl. Okay, chloromethane. Now this chloromethane, further you are going to treat it with sodium in the presence of dry ether. Okay, and you will get ether. So we know that 2 molecules of this. So it is option. Okay. So what you can do? So further you are going to treat it with chloromethane. So we are going to do it chlorination followed by Woods reaction. Okay. So option number D, 3. Option number 3. Yes, option number 3 is the answer. So who all have answered as option number 3? Yes, it is a correct. Very good. Okay. So option number 3. So what we are doing? First, we are converting our chlorine. We are converting the this what chlorine gas. We are reacting with methane in the presence of UV light. Okay, we get methyl chloromethane. This chloromethane, 2 molecules of chloromethane, we react it with sodium in the presence of dry ether. Okay, and what we get? We get ethane. Okay, so this is the answer. Okay, Let us go for the next one. Okay. Intramolecular hydrogen bonding is found in. So in which of the following intramolecular? So there are two types of hydrogen bonding. One is intra and one is inter. Okay. Inter means between two different molecules, and intra means within the same molecule. Okay. This is within the same molecule, and this is between different molecules. Okay. Remember these important points. Don't get confused between what is intra and what is inter. Inter means different molecules. You can remember like this, inter-college competitions, okay? And intra means within the college, the competition. So like that. So intramolecular hydrogen bonding and intermolecular hydrogen bonding. So they have asked in which of the following compounds intramolecular hydrogen bonding is seen. Intramolecular hydrogen bonding is found in water, salicylic aldehyde, ammonia, or benzophenol. So let me write the structures. Okay, let me write the structures. So this is your benzophenol. So this is your benzophenol. Okay. So what is the necessary condition that it should have a free okay, so this is your OH, and you have your, so this is your salicylic then NH3, and H2 is like this. Okay, so water, it forms the hydrogen bonding, but it forms intermolecular hydrogen bonding. Ammonia, okay, it can also form, but it cannot form here. Now, when you see benzophenone, there is no free this, okay, H, you can see, you cannot see any hydrogen here, free hydrogen. Now here, when you see between the in the salicylic, so between this hydrogen and oxygen, the hydrogen bonding is possible. So it is option number 2. Yes, who all have answered? Yes, V. Lingakani has answered. Very good. Okay, so within the molecule, within the same molecule, you can find the hydrogen bonding. So you need to write the structure. Okay, you need to write the structure. So structure is important. Let us go for the next one. If 50% of the reactant is converted into product in the first reaction in 25 minutes, how much of it would react in 100 minutes? If 50% of the reactant is converted into a product in a first reaction in 25 minutes, how much of it would react in 100 minutes? It is second one. Just now I told no salicylic. So I've written the structure also. Okay, see here. So this is salicylic structure. Okay, you can see within the same molecule, hydrogen bonding is found. So option number 2. Okay. Okay. Next question. We are seeing 15th question. 15th question. What is the answer? Okay. Madan has answered it as 4. V. Linga Kani has answered it as 1. Vamshi Krishna has answered it as 4. Okay. So if 50% of the reactant is converted into a product in the first reaction is 25 minutes. Yes, how much it would react in 100 minutes. Others, yes, try to answer. Very important. So this is the from chemical kinetics. Okay, so this question is from chemical kinetics. If 50% of the reactant is converted into a product in a first reaction in 25 minutes, how much of it would react in 100 minutes? Okay, 93.75%, 87.5, 75, or 100. Okay, Madan has answered it as third one. So given the percent, okay. So if 50% of the reactant, if the 50%, so reactant giving you product. So if 50% of the reactant, okay, if it is converted, so that is it is converted into product, okay, in 25 minutes. So 25 minutes, how much it would take for 100 minutes, okay, for 100 minutes. So what you can do, so what is the percentage? So we know that what we know, so that is K is equals to, okay. So what all we know here, we'll write here. So Shweta has answered it as D, okay. So let us see, I want the slide here. Okay. I'll take it this side, okay. I'll zoom in. Okay. So let me take this side. Okay, I can write it here. Fine. So let me solve it here. So, okay. So what all is given if 50% of the reactant is converted into product. Okay. So T half is given. T half is 25 minutes. Okay. So T half is equals to, okay, what we have to find how much it is, it would take in 100 minutes. So let us find first rate. So T half is equals to 0.623 by 25. Okay. Sorry, by K by K by K. What is K is equals to? K is equals to 0.623 by T half is 25. Okay. So for first order, we know that T is equals to 2 point. So K is equals to 2.303 by T. Okay. Log of A by A minus X. So what we have to find? We have to find the time. So let us take time here. So it will be 2.303 by K. Okay. Log of A by A minus X. Now here, what all we know? So log of A by A minus X is what? That is equals to, okay, log of A by A is equals to, so 2 tx into 2.303. Okay, so how much it would react? So 100 time is how much? 100 this. Then K is equals to, so it is 0.623 by 25 into 2.303. Okay, so log of A by A minus X is equals to, so after solving this, how much you'll get? Just see. So 4, okay, so you get 4 log of 2. Okay, so after taking anti-log, so okay, so you'll get 4 of, just see, solve it. So 100 into 0.623. So this is 62.3 divided by 25 into 2.303. That is 57.575. Okay, so it is 62.3 divided by 57.575. So it is 1 point, this what? So it is 1.0 8. Okay. So when you take anti-log on both the side, so 100 into 0.623 divided by 25. Okay. So when you take anti-log on both sides, so you will get here the value as 2 raised to 4. Okay, that is 16. So if 100% is your this, so 100 minus this what? 4. Okay. So 40, it will be 60. So you will get 100 of 100 minus 16. Okay. The answer will be 93.75. So option number A. Okay. Option number A is the correct answer. So like this, you have to find the T half and then put the values in the first order reaction and find the okay how much this will be percentage it is. Okay, how much is reacted? It would react in 100 minutes. So you will get first option. So the number of optical isomers of the compound CH3, CHBr, CHBr, COOH is. So the compound is CH3, CHBr, CHBr, okay, COH. If I write like this. So 1 CH3, CHBr, okay, then CHBr, COH. Okay. How many optical, these are possible, optical isomers are possible in this? There are two chiral center, right? So 1 and 2 chiral center. So 2 raised to 2. 2 raised to 2 is 4. So option number 4. Okay, 2 raised to 2 is 4. So option number 4. Yes, Madan has answered it correct. Very good. Okay. So next question. So this is from metallurgy, leave it. So next question is 18th one. Go through the 18th one question. The rate of reaction increases with rise in temperature. Okay. So why does the rate of reaction increases with the rise of temperature? Because what happens, increase in number of activated molecules, okay, increase in energy of activation, decrease in energy of activation, increase in the number of effective collisions. Okay, so what happens here? So why the rate of reaction increases with the rise in temperature? So when so this is from your okay, so activated energy. So when you see this, what you can see, so the rate of reaction. Okay, what will happen to the rate of reaction with increase in temperature? Yes, it is option number. The rate of reaction increases with rise in temperature because of. Okay, Vidya has answered it as 4. Madan has answered it as 4. So the energy and speed, okay, as the temperature increases, the rate of reaction also increases, right? So the rate of reaction increases with rise in temperature because of. Yes, option number 4 is the correct one. Okay, so what happens? the energy and speed of the molecules of the reactant. Okay, what it happens, it increases with the increase in temperature. So the number of molecules, okay, what will happen? It will increase with the increase in effective collisions. So the rate of energy increases with increase in temperature. So option number 4 is the correct. Very good. Okay, let us go for the next one. Okay. Meso compounds do not show optical activity because of. So why does meso compound do not show optical activity? What is the reason? So this is a question from haloalkanes, haloarenes. So what are meso compounds? Meso compounds are those compounds where half of the molecule is it will compensated by other half, and there is a presence of plane of symmetry, right? So this is the meaning of meso compound. So why does meso compound do not show optical activity? Meso compounds do not show optical activity because it contains due to the plane of symmetry. Okay, as it contains a plane of symmetry. Okay, so so because of the plane of symmetry, what happens? The one half of the molecule is so suppose I take this particular molecule, that is COH, COH, H, COH, H, and COH. Okay, so if I see the molecule, half of the molecule, if I keep a mirror image here, what you can see, so this is a plane of symmetry. So there is a plane of symmetry present here. So what you can observe, that one half of the molecule is similar to the other half of the molecule. So what will happen? It will get cancelled out, right? So because of the plane of symmetry, what will happen? They do not show optical activity. Yes. Third one. So Vidya has answered this. Third one is the answer. Okay. Let us go for the next one. When formic acid, okay, so when formic acid is heated with concentrated H2SO4, the gas evolved is. Madan has also answered this third for the previous. Okay, let us go for the next one. When formic acid is heated with concentrated H2SO4, the gas evolved is. Yes. So which is a gas evolved. So when formic acid, okay, when it is treated, so this is your formic acid. Okay, when it is treated with concentrated H2SO4, okay, what it gives you? It gives you carbon dioxide or carbon monoxide. So gas, which is a gas evolved here. It will give you carbon monoxide plus H2O. Okay, carbon monoxide gas, and this is a liquid. So you will get only CO. What will get? Only carbon monoxide. Yes, Chinmaya, Vidya, and Vilinga Kani has answered it as 2. Very good. Okay, so your answer is right. So it will yield only yes. Okay, so 2 is the correct answer. Let us go for the next one. Temperature coefficient of a reaction is 2 when temperature increased from 30 degrees Celsius to 90 degrees Celsius. The rate of reaction is increased by. So this is another question from chemical kinetics. Temperature coefficient of a reaction is 2. When temperature is increased from 30 degree to 90 degree, the rate of reaction is increased by. Okay, Madan, Chinmaya, Vamshi, Krishna, Vidya have answered. Temperature coefficient of a reaction is 2. When temperature is increased from 30 degrees Celsius to 90 degrees Celsius, the rate of reaction is increased by. Velinga Kani has answered it as 2. Madan has answered it as 2. Yes. Okay, first one 60 times, 264 times, three 150 times, and fourth is 400 times. Okay, Sanjana has answered it as 1. Now here, okay, so what is the temperature coefficient? Temperature coefficient is given as 2. Okay, and change in temperature is what? Change in temperature is that is from 30 to 90. So how do we take 90 minus 30? So that is 60 degree. So the change in temperature is 60 degree. So 6 times to the value of 10 degree, right? So this is 6 times. So this is 6 times by 10 degree. So temperature coefficient is what? It is a ratio of rate constants when the temperature is increased by 10 degree, right? What is temperature coefficient? It is a ratio of rate constants when the temperature is increased by 10 degree. So what is the rate of the reaction? So the rate of the reaction is increased by 2 raised to 6. Okay, so that is 64 times. 2 raised to 6 is 64 times. So option number 2 is the correct answer. Option number 2 is the correct answer. Okay, let us see. Yes, option number 2. Is it correct? Got it? So temperature coefficient is given, that is 2. Okay. Now, what is the change in temperature? That also we have seen. So change in temperature can be calculated by higher minus lower. So 90 minus 30 is 60 degree. So for every 10 degree rise in temperature, okay, so the rate constant will be increased. So the ratio of rate constant is when temperature of the is increased. Benzene to acetophenone can be converted by. So it can be converted by what? It can be done by. It can be done by Friedel-Crafts. Okay, Chinmaya, Vilingakani. Okay, Triveni has answered it as 4. Vamshi Krishna has answered it as 2. Vilingakani has answered it as 4. Chinmaya has answered it as 3. And the answer is fourth one. Okay, it can be done by Friedel-Crafts acylation. By doing Friedel-Crafts acylation, we can do what? We can do the this what? We can introduce the acetophenone group. Yes, Madan has also answered as 4. Okay. So we have completed some 22 questions. Okay. We have left with some 28 questions. Okay. So let us do this remaining questions in the our next class. Okay. Is it clear? So we have solved 22 questions. So any doubts up to here? Yes. So like this. So in the span of time, you have to complete all the 60 questions. Okay. So is it clear? Yes. So the continuation of this particular paper we will be doing in the next class. Okay. I hope you have understood. Yes. So please solve some previous questions. Okay. Fine. So thank you. So I'll be ending this session here. Okay. We'll meet in the next class. Thank you. Have a good day.